In this section of the course, we will cover step-by-step instructions for how to get the data ready for modeling, as well as some initial setup requirements to use the code that comes with the course. So the objective of this course is to get the data ready for modeling, and that involves a number of steps that we're going to cover in some detail here. First, of course, how to load the data into R. We're going to also use oversampling to improve the efficiency of the code we're going to run going forward. We're going to use loaded data dictionary and how we can make use of that in R. We're also going to cover some simple quality control steps and some report generation that's very useful to do as a first step of the project to make sure that all the data imported correctly and everything is in order. And we're also going to cover how to do some initial data transformations. So at the end of this class, you should be able to have the data ready for the next step, which is modeling. And you should also hopefully have the experience and code required for your own projects later on. The code might need some minor modification, but hopefully it should be a very good starting point for your next project. Before we get started, some bookkeeping issues. The code is written assuming the file structure shown to the right, where there's a data folder that contains all the data file, an R folder that contains different R projects, and this particular project is stored in the Logistic folder. Now you don't have to use this file structure, but if you don't, you may have to change some of the file paths in the code. If you save everything in this structure, the code should run without problem, regardless of what operating system you use, if you use Windows, Macintosh, or Linux. So now we're ready to start the hands-on demonstration of how to do this first step of the modeling process. And the files you're going to need are the data file cup98lrn.txt, and the code we're going to use is available in the file step 1 prepare data. So we're now ready to get started, and we're going to use RStudio. Now that's not a requirement. You should be able to run the code using whatever implementation of R you have, and regardless of operating system. But I like using RStudio because it's got a very good text editor for the coding, and also some advantage in terms of how you manage your project. And I'm going to just cover RStudio here in a very, very high level before we get started on the actual project. So when you open RStudio, you get 4 windows like we see here, where the upper left corner is your text editor where you edit your programs. If you don't use RStudio, you would just use your favorite text editor for doing the program. So now we can start with opening the project file that we're going to work on. Here, the step 1 prepare data, that's the file we're going to be using. And as you can see, it does very nice color coding where you have your comments in one color and your code in one color and your option in another color. So it makes the code more readable and easy to use. And then in the lower left corner, you have the console where you're actually gonna run your command. In the upper right corner, you have 3 different tabs. One is the workspace that shows all the variables you have stored in your workspace. So let me say we create a variable x that we assign the number 5. So now that one show there. Let's do another variable that we have a matrix with some random numbers in it. So now we have, it shows the data for that matrix there in the workspace. But let's just clear that. We're not going to need that going forward. There's also a history tab that contains all the commands you used in the past for this particular project. And that can be very useful sometimes if you want to do something, repeat something that you did in the past, and then you can just highlight that code and then says, do I want to copy that to the console or do I want to copy it to the source file? The third tab here you will only see if you have installed Git. Git is a version control software, and I'm not going to cover that here, but I highly encourage you to look into it. It's very useful, especially if you do large project. It allows you to take snapshots of your code, and then if you make some mistake that creates some problem for you, you can go back to earlier versions of your code. So that's very useful. In the lower right corner, you have 4 tabs. First, there's the files, which is all the files you have in your projects folder. And then there's the plots tab. So if you generated a plot, they will show here, and you can navigate back and forth between the different plots you created. And the third tab shows all the packages that's installed on your computer, and the ones that's currently in use are marked with a checkbox. And finally, we have the help system, where you have all the links to all the different information where that you can use to obtain help. If, for example, you want help with generalized linear models, you can just type $GLM, and the help will show up in the screen on the lower right. When we start this, we want to have our working directory to be the same directory where we have our R scripts. That's how the files are written. To check that that is the case, you can use the get work directory command, and you see now we're in the logistics folder, which is what we wanted to be. Now if you're not in that folder, you can just go up to session and then go to set work directory, and then you can choose your directory, or if you have opened a file, you can just set it automatically to the source file location. So now you can see it just used the set work directory command and changed the working directory to the same folder as the file I had already opened. Another thing you can do if you use RStudio is to create a project. When you create a project, then you just point to the folder where you have your files, and then each time you open that project, you will automatically have your working directory set to that folder. So that's another thing you can do. But that only applies to RStudio. That doesn't apply to the general implementation of R. We're now ready to get started on actually loading the file into R. The code we're going to use for that is in the file step1 preparedata.r that I've loaded into RStudio here, and the file is in the file cup98lrn.txt. So it's a simple text file, and we're going to use the command read.csv to load it into R. And let's have a look at the command read.csv. And if we look at the help file here, you can see that the command comes with a number of options that you can specify. Most of them have default values, so you don't have to specify. The only value you really have to specify is the file name. Then if the other options match the structure of your file, you should be good to go. But there's a number of options that are good to be aware of and the impact that they have on the process of reading your file. I'm not going to go through all the options here, just a few that are important. First of all, NA strings. What was the format of your missing data in your file? The default is NA, but depending on the software used to export the file, it might have different standard for how to specify a NA value. Another very useful option is the N rows, number of rows you want to read in. -1 means that you want to read the entire file. First time you read a file, it might be very useful to just read in 100 or 200 rows to see that it reads properly, rather than spending several minutes reading a huge file, you only to find out that it didn't read it correctly. The skip option lets you skip a number of rows at the beginning of the file. Sometimes you might have a file where the first 10-15 rows specify some general information about the data and it's not really part of the data, and this option lets you skip those rows. The last options I'm going to talk a little bit about is the comment character. The comment character specify what in your file should be considered a comment and not read as regular data. And this can sometimes generate a problem. Let's say you have a text string in your data where your text string contains this character. Well, then what will happen is that R will interpret this as a comment, and then your data will be misaligned, and you will typically get an error message specifying that your number of columns are inconsistent. And when that happens, the first thing I usually do is go back and check and change the comment character to just the empty character, an empty cell, so that nothing is considered a comment, because that's most of the time how the file would be specified. So now let's read the data, and let's just first read a few rows of data. So let's read the first 20 rows of data. And as you see, we now have the data in the workspace here with 20 observations, and we read 481 variables. And let's have a look at the data. In RStudio, it's very easy. You just click on the data, and then it opens up a window where you can look at it, and it looks like it was reading in properly with the values in all of the columns, and we see what we expected to see. Now, if you don't use RStudio, you can use the edit command. So let's do that. And here again, you can see we look at the data, and you can go through the data and see that it looks all right. So now we're ready to read the entire file. So let's change this option back to -1, which indicates that we want to read the entire file. Now this is a large file, so it will take a little bit of time. And while it's reading, I'm going to talk about one good practice, and that is to save the data in the native R format when you're done. The reason for that is if you later want to load the data, it's much faster to load it from a native R file than from a text file. So now it's finished loading the data, and let's just save a copy of the data in the native R format that will later on load faster if we want to restart. And it's also very memory efficient. Typically the files stored as a R file is maybe 1/3 to 1/4 the size of the original text file. If we later want to load the data again that we saved in the R format, we would just use the load command. So we run it here. And you see here it took less than a second to reload all that data. And we can see now we're reading in 95,000 observations and still the 481 variables. So let's start looking at what we have. We're interested in the target B value, which indicated if there was a response to the mailout or not. So we want to know the response rate. And here again, what we care about is this command where I calculate the average response rate. Now, as you can see, I included that in a cat statement that would show the result if I ran the entire file instead of just this one line. So let's run this. So we'll see, okay, our average response rate was about 5%. Now, that's not, for modeling purposes, it is more efficient to have a more balanced data set where there's about equal number of responders and non-responders, or at least not this unbalanced. To get a more balanced data set for modeling purposes, we're going to oversample the responders. So in this data set, we want to keep all the responders, and we want to take a sample of about 10% of the non-responders. And by doing that, we significantly reduces the file of the size of the file we're working with, and our code will run much faster. Now this will result in a biased model that will overestimate the response rate, but that we can account for at the end to account for the fact that the data was oversampled, and then the output will still be correct if we properly account for that at the end, and that we will cover in a later section how to account for this oversampling. So to achieve this oversampling, we're going to use the sample command in R. And before using the sample command, it's usually a good practice to set the initial seed for a random number generator, because that will allow you to regenerate exactly the same data set again if you want to. The set seed command accomplishes that. So if we, for example, now generate 10 random numbers, we got 10 numbers. We generate the number 10 numbers. Now let's reset the seed to 10 again. And you see now that we perfectly generated the original first 10 samples. So this is a method where you want to use a random number generator, but still be able to guarantee that you can regenerate exactly the same code again and again if required. So now we're going to generate a sample. So I'm going to use the sample command, and let's look at the options for the sample command. So first you specify what you're sampling from, that's the X. Then how many samples do you want? Do you want to replace, do you want to sample with replacement or without replacement? And then finally, do you want to have different probability for the different items you're sampling from? The default is that there's an equal probability to select any one record. So what do we want to sample from? Well, we generate a vector going from 1 to the total number of rows in our data. So from 1 to 95,412. And we want to sample 10% from that. So we take the number of rows in the data set, multiply by 0.1, and round that to an integer. And then generate our sample. So let's do that. So now we have a sample vector. Let's look at the first 10 entries. So it selected record number 82505, 58712, and so on. And in total it selected randomly 10% of the record. Now we wanted to include 100% of the responders. Since we have much fewer of them, it's important to keep them in the data set. So to accomplish that, I used the union command. So I took my 10% random sample. Then I again generate a vector going from 1 to the total number of rows in the data set. And then I specify I only want to include the records where my target variable equals 1. And then I create a union of my original sample plus the sample that includes all the responders. So if we look now at my 10% sample, the 10% sample included 9,500 record. Now I do a union and combine that with 100% of the responders. So now I have 13,900 records in my sample. And then all I have to do is to specify that in my data, I only want to maintain my sample. So if you remember, we had this data set with 95,000 records and 481 columns. Then I specify I only want to include the rows included in my sample. So now I have my sample of 13,900 record. And let's look at what the response rate is for this oversampled data set. So now we have 34% responders or 35% responders, which is a much more balanced data set that would be more efficient for modeling going forward. And let's take a backup of the data. This is just something I do once in a while because now we started a process, and if I do something that messes up my data, I can go back to my data backup. I don't have to start all the way from the very beginning. So we now successfully have our data set loaded into R and are ready to move on to the next step of the process of doing modeling. But before we do that, I want to talk a little bit about other ways to get data into R. And here we use the text file, which is a pretty common way to get data into R, but there's many other ways. And there's a couple of packages that are very useful for the purpose of getting data into R. So if we look at packages here, one package is foreign, which contains support for reading data stored by Minitab, SAS, SPSS, and so on. So that can be very useful if you get data from any of those sources. And I'm not going to go into detail here, but you have the information here and can read about the different command. And what's nice about R is that if you click here on any of the commands, so let's say read a Minitab file, at the very end they always come with examples of how to use the code. Another package that I find very useful is the RODBC package. So let's see where that is. Here we have that. And that's a package that supports the use and connection with any data source that supports the ODBC standard. So you can use this to connect to an Oracle server, a Microsoft SQL server, or an Access database, or even Excel supports ODBC. So that can be used to get data from a lot of different sources. Now I noticed with Excel it's a little bit trickier on a Macintosh to get that working. On a Windows computer there would be a specific command to load the data from Excel. That command is not available in the Macintosh version of R. But if that's something you want to do, I'm sure there are other packages that can do that. Just go to the R website and search. There's so many packages that supports all different kind of methods to get data into R. And if the data is in an Excel file, you always have the option in Excel to just save it as a CSV file and then just use exactly the method we showed here to get the data into R. So that completes this section of the course. So I hope you enjoy it, and let's move on to the next section.